mode.
Hello everyone, welcome to SITAC webinar series. My name is Rakesh Malakar. I'm one of the members of SITAC organizing team. We have a very exciting presentation today on information architecture. And we are joined by a special guest. His name is Lucas Hirinawuki. He works at Costco as a data architect. Prior to joining Costco, he worked at Microsoft as a data architect for many years. Before we start, during the presentation, if you have any questions, please type it in the question box. Lucas, the floor is yours.
Thank you, Rakesh. A quick sound check, if you can confirm.
Yes, I can hear you.
All right. Well, thank you for joining us. I believe Rakesh was telling the truth. Tonight, I'm going to introduce you to the most interesting and exciting domain in the enterprise architecture portfolio, data architecture. We also call it information architecture, and I'm going to explain about that a little bit later. But more or less, data architecture or information architecture, it's used either way. Since I'm a
Lucas, I think we lost you. Just hold on a second.
Well, I'll give it a try. Rakesh.
Yes, I can hear you now.
So what? Well, I'm trying to figure out what really happened, since I haven't changed anything.
Okay.
I'll keep the audio bar open, so I'll see maybe when I'll drop off.
Okay.
But ping me if you actually see that.
Okay, I'll do that.
Again, I don't know what happened because I didn't really change anything.
Yeah.
All right. So maybe that's my headset, probably. I don't use it too often. If that's the case, it will happen again, I'll switch to a phone.
Okay, no problem.
All right.
We can hear you
Where did I stop?
when you just started. So start from the beginning.
Really? All right. That's that's painful. All right. Well, I'll give it a try.
Yes, no problem. Technical difficulties.
All right. That was weird. Okay. So anyways, I'm going to repeat myself, but Rakesh didn't lie. We have a good session tonight. We're going to talk about the most interesting domain in enterprise architecture portfolio. We call it data architecture. It's also known as the information architecture. And I'm a data architect, so keep in mind I might be slightly biased towards data. But I think the data in a general sense, data field in general sense, is becoming more powerful. It's not only affecting businesses, but also our personal lives. So that's why I got the subtitle, The Power of Data, on the slide which you're looking at right now, and it should be visible, I hope. By the way, this is the picture I took myself on August 21st, 2017, during a solar eclipse over Seattle. And if you were observing the same event and you're wondering why my picture is so much better than yours and how did I get a full solar eclipse while we only had the partial sun eclipse over Seattle, well, I used a bit of help from Photoshop. So let me build some credibility for data domain. And usually when we build credibility, we try to pick something from the past and say, oh yeah, that law is established in 1800 something, therefore it's the most powerful law, and so on. I'm going to move you back, way, way back. I'm going to move you to ancient Egypt. The date is 2580 BC. That's like 4,500 years back. And we are about to start the biggest man-made man-made building in human history to date as a part of the Public Works project. Public Works meaning that citizens have to participate. And by the way, that tallest man-made structure in the world stood for another 3,800 years without any competition. And by the way, it was known at the time as Khufu's Horizon, after the pharaoh names, which is also known as Cheops by Greeks. Well, let me introduce you to the project itself. Well, project is well sponsored. The pharaoh, who is the king on steroids, is basically standing behind it. There's also a bunch of stakeholders, mainly ruling class, with a vizier on the top. Vizier is like a prime minister. So, well-sponsored project, really good stakeholders, but there's still some issues with that project. So let's get a little bit deeper into it. Well, apparently there is no problem with the architecture. The vision is clear. They also have some kind of diagrams describing what needs to be built with dimensions. Everything seems to be right. Now, engineering department provided lots of information. They already identified the materials. One of them is limestone, coming from a nearby quarry. It's just across the Nile. They also calculated the number of blocks, the stone blocks, and it's about 2.3 million blocks with the size of 2 to 10 metric tons each. They also need maybe not that much, but also need additional stone, granite, which is far, far away. They also identify the size of the objects. They have blueprints. They basically have everything to start building it. They also identified that there are certain constraints, engineering constraints. They don't know the wheel yet. The wheel is known in the world, not in Egypt though, and they don't have any iron tools. So there's also a quality group who defined that in order for this building to survive earthquakes and anything else which this building may face in the next 5,000 years, the precision has to be unprecedented. Basically, the precision of each stone, cut, carved, and polished, has to be to 0.05 millimeters, which is 0.02 inch. This is more or less like a passing bar set up by a quality assurance department. Now, the GPMO office, which stands for Great Pyramid Management Office, also figure out how to build it. Since they're responsible for scheduling and making sure that the tasks are properly aligned, they're also responsible for planning workforce. They figure out that that pyramid needs to be finished on a specific date. It's 2560 BC. So it gives the project about 20 years to complete. And they quickly calculated that if one block, it's put on the top, actually cut, brought in, polished and positioned every 5 minutes. And if the workforce works 24/7 for the next 20 years, that goal is very achievable. And they estimated that the required workforce will be about 250,000 workers. And that created a problem. And the problem is very difficult to overcome. It turned out that Egyptians are not motivated to build another pyramid. They already built a couple of pyramids around Giza, and they don't have a big appetite to start building another one, especially the biggest one. Plus, the population of Egypt at that time was about 2 million people, so 250,000 citizens who need to dedicate their lives for the next 20 years to build a pyramid. That means that almost each family has to give up someone, and most likely never see that person again. So the obvious problem is how to motivate those 250,000 citizens to build the pyramid and the rest of population to support that building the pyramid, meaning paying more taxes. Well, you may think that maybe you could force the population, but unfortunately the army wasn't that big. Even if they actually forced the population to build it, they wouldn't be motivated. Definitely they wouldn't be able to finish on time. And if they start civil war, then most likely neighbors are going to invade them. So that's not an option. So the only option is motivate the citizens to actually build it. So they were kind of in a difficult position. so the vizier who is organizing the whole event is trying to basically reach to every single scientist at the time, which is mostly priests, and nobles are kind of useless because they don't really study that much. So the vizier is in the difficult position of trying to figure out how to do this, and he's faced with the reality that maybe they won't be able to actually build it. And to his rescue comes a tiny department, a data science department, which basically tells Vizier that they have some kind of information which they think it could be useful. Well, Vizier was ignoring them for a long time, but not having any other options, he decided that maybe that's a good idea to actually listen to them. And it turned out that the information they provided allowed him to craft the whole event, which I'm going to unfold right now. Well, the letters were sent to every single family in Egypt to join the big event. The event would be on a specific date. The event will be probably like last 2-3 days. They're encouraged to come early. The food will be provided, the drinks, shelter, everything will be provided. And they encouraged to have at least one person from each family to join them in that event. Now, the interesting part is that nobody truly knows how this event is going to look like. Well, the main event was introduced to people, and the event was introduced as something which they never heard about before. They're supposed to vote for building the pyramid and increasing taxes, or against building the pyramid and reducing taxes. And those were the only two choices. Well, as you can probably imagine, free event, free wine, free food. Many people actually showed up. Almost 250,000 people showed up. They collected all the votes, and then on Sunday, the main event started. The main event started precisely at noon, and Vizier himself stood on the podium and basically addressed the people, saying that the country is going for the change. They decided from now on that government is going to listen to the people, and they're going to count the votes, and whatever people decide, government is going to execute. And he said that he has results for the votes, and that they're going to, and he's going to announce it now. Well, it wasn't a surprise for people that majority of people were against the taxes, increasing of taxes, and against building the pyramid. Well, he read the results. People didn't know what to make out of it. That means it, or they're going to actually stop building the pyramid and they can just go home. What's going to happen next? So Vizier said that he already talked to Pharaoh, and Pharaoh said that he agrees with people. He has no problem with that. But he's only the ruler of the Egypt. He's not the ruler of the whole world. So maybe it would be wise if they took that decision just for rubber stamp approval to someone who is more important than him. Basically, he asked to talk to the sun god, who was at that time the most powerful god known to Egyptians. His name was Ra. And if God Ra is going to approve that, or is not going to at least disagree with that, then the decision is final and everyone can enjoy their free time. So now the ceremony slightly changed. The priests who were in the business of talking to gods started dialing in. They sacrificed some animals. The blood was flowing, and they brought the voice of people to the sun god, basically telling the sun god, Ra, sorry, but we're not going to build you another pyramid. People decided that, you know, we don't need another one, and we hope that you're going to be fine with that. Well, since they never actually witnessed, people of Egyptians never witnessed that kind of direct talk to gods between the priest and gods, they didn't know what to expect back, especially from the god. So they didn't know if God is going to speak, if God is going to, what sign God is going to give them, right? So some people were skeptic, thinking that priests are actually, they're going to lie, they're going to tell them something which maybe they already crafted. So they were kind of skeptic about the whole thing. But there was what happened next, there was no ambiguity what the answer from the sun god was. Slowly, the sun started disappearing. In the middle of the day, sun basically, God Ra took the sun away, and in the middle of the day, which turned into night, God Osiris showed up. Some people actually said that maybe that was just a priest, smart priest, creating some kind of illuminated version of Osiris. It wasn't Osiris, but nevertheless, Osiris was the god of that and ruler of the underworld. So nobody was messing up with Osiris. Plus, you know, you can say anything about priests, but nobody can take sun away in the middle of the day. So they knew that was God Ra. Now people start praying and crying and thinking that, you know, they weren't ready to join Osiris yet. Definitely they weren't ready to sacrifice their families and children. So they didn't know what to do. So some people start chanting, maybe we should build a pyramid. So build the pyramid, build a pyramid. And people picked it up. Well, priests didn't waste their time. They definitely said, if that's the will of the people, we should probably call God Ra. He still must be close by. Let's rush it up. If you want to build a pyramid, and definitely you'll need to pay more taxes, we can take this promise to God Ra, but you have to stick to that promise. Well, everyone quickly agreed, and priests did another dialing. So they call God Ra. They sacrifice some animals, sacrifice some slaves to speed up the dialing, and God Ra, since he's a merciful God, brought back the sun, and that's how we got the Great Pyramid of Giza, which is one of the 7 wonders of the world, and the only one which actually survived to our times, if you didn't know that. So that's a nice story, you can say. Naive people. But look at these people 4,500 years back at the event which nobody could control and nobody knew about. And the interesting part was that they were able to use that to their advantage. Now, if you think about the current dates, current days, then there's no question that type of event wouldn't probably work the same way. But that the power of data, it's something which has been with us for a very, very long time. There is a, I don't know if you know that, but there's a missing link between how we converted from hunters and gatherers to large civilizations. Like even ancient civilization like Egyptian civilization was 2 million people. And that was related to adoption of written language and data. Because in order for any civilization to exist in a large number, the complexity of that group basically creates impossible task, keeping track of everything what matters for that civilization. And with introduction of data, which was basically done in different ways, initially on clay tablets. Sumerians actually came up with that idea. They had clay tablets, which they basically wrote everything on it. They had business transactions. They had information about events. They had information about astronomy. They have some myths written down. They had pictures on those clay tablets. The clay tablets are when they actually create them, they're soft, right? But then they put them in, basically bake them, and then they become solid, almost like stone. And we discovered so far about 1 million of them. It's like, you know, you think about that's like almost like ancient internet. All type of information it's in there. And the interesting part is that we only translated about 20% of them. So there's still 800,000 of those tablets which are waiting to be translated, and lots of interesting info to be actually learned from it. But then you look at the power of data today, and you look at what information big companies actually have on you. Like Facebook knows you probably better than your partner. At least they proved that. Google knows you when you get the flu, most likely 2 or 3 days ahead, because they're reading your emails and IMs, and they're scrapping all this emails, whatever words you're putting in there. They're running it through machine learning algorithms, and they think, yep, he or she is going to get sick pretty soon. Well, there's many stories how data basically got used, especially by organizations which have ability to gather and process lots of data. And the most interesting part is that with introduction of artificial intelligence and machine learning, we're entering into something which we never had ability to do. We're entering into interesting ways of predicting or priming people and predicting their behaviors. So it's going to be probably very, very interesting future coming up based on data evolution, which is still ahead of us. So the lesson number 2. When we look at the approach ancient Egyptians had to the construction work, we see lots of concepts which, if you're in software engineering, you're very familiar with. From architecture, through engineering, through project management, even quality control. And the question would be, is that something which why have so many similar approaches? And the answer is very simple. We just didn't have any. When industrial adoption of computers happened, and universities started producing armies of software engineers, we faced the reality that we didn't really have a prescribed way of doing software engineering. So what we done, we borrowed lots of concepts from the other engineering discipline, which was civic engineering, and we actually have tangible examples. John Zachman, the creator of one of the first frameworks for enterprise architecture, called Zachman Architecture Framework. When he started looking at the problem and trying to solve it in computer science, in software engineering, he actually reached to a friend of his who was a civil architect, and he shadowed that guy and trying to figure out how a civil architect approaches the architecture. And then he transposed those ideas to software engineering, and that's how we got Zachman's framework, which many companies actually have been using for like a decade now, and still successfully using and very happy with it. And you know that Zachman framework is one of those many frameworks, so it's not perfect, but it works. It does work. And this is the most powerful lesson out of this whole story, which is the first data pattern, which I'm going to introduce tonight, which is the transformation of data to information and then eventually to intelligence. So what happened in ancient Egypt is that those Sumerian tablets got translated in Egypt, and they had lots of data about basically tracking down our sun, since our sun was one of the most affecting object on the sky. There was many religions and civilizations who actually track it very closely, and Sumerians were one of the people who recorded that like painfully through millennia, the sunrise, the sunset, and they also recorded that every so often the sun would disappear in the middle of the day and then appear back, and then then this event wouldn't happen again for tens, maybe even 100 years, and then appeared again. So over a long period of time, the certain patterns were discovered, and those patterns were something which the data science department, which I mentioned before, got hold on, and they not only they understood those patterns, but they were able to create a model, prediction model on the top of it, which gave them the ability to predict the next event. And the next event, that was the event which they described, the sun eclipse in Egypt, was that information was given to Vizier. Vizier recognized that this is the event he was waiting for. He shared that event with nobles, and they quickly came up with the whole event, like what needs to happen and how. They were able to combine their business knowledge basically with that information which was presented to them by data science department. They knew their customers very well. After all, they were ruling them for centuries, no? So what they done, they combined this knowledge with that information, and that became intelligence. And intelligence is something which has the power of a strategic use, meaning that you basically act on it because this intelligence gives you something which otherwise you would never achieve. So this is the first data pattern, how data goes from the raw data, basically something which we gathered from our systems, from different sources, then identify some patterns and basically present those patterns in the way that business can interpret them. So usually what you do, you try to present this in a way that business can can make sense out of it. And then business takes that information and combines that with the business knowledge to create that powerful intelligence. The most interesting part is that this was used in ancient Egypt 4,500 years back, and we're using the same pattern today. And even more interesting is that we actually present it in the form of this type of pyramid, and you've probably seen it a few times at least, because every time anyone talks about data, usually that pyramid shows up somewhere. And there's tiny variations of it, but in general sense, it has those 3 layers, which are truly meaningful. Now, the interesting part is that the top of this pyramid, that intelligence, used to be reserved to people, in a sense that business in this context means business people who understand the business very well. But now, so they can digest the information and they can come up with some kind of action on the top of it. But now AI, artificial intelligence, actually we're sharing that space with AI, and AI is able to interpret that information and come up with the action and execute it as well. And you've seen examples of some of the power of artificial intelligence: self-driving cars, smart devices like your phones can track you down, can tell you when the next meeting is, if there's traffic on the way. There is smart watches, and the examples go on and on. So the interesting part is that this is something which is still waiting for us to happen. We don't know how this is going to evolve. We don't know how well those machine learning algorithms are going to perform. But even now, we start looking at those algorithms, and we know that we're at the point where we know for a fact that they're going to be very powerful. And I'll give you a simple example. I think it was like 1996 or 97. The IBM Deep Blue, which was a supercomputer built by IBM, won a couple of games with Garry Kasparov, who is a grandmaster in chess. And that was a huge event. That was like over 20 years back. Why? Because up to that point, nobody actually believed that the machine could match cognitive power of human brain, since there are so many moves in chess, and that was basically impossible for a machine to do it. So what happened last year, the Google spin-off, which is basically AI division of Google, created a software which is called AlphaZero. And AlphaZero doesn't play against people anymore. I mean, it plays against Go, a game, not chess. But in chess, since it's an easier game, it actually played against another piece of software called Stockfish. And right now, what people actually do, they observe how those two algorithms play against each other, because the way they play, especially AlphaZero, it's so unique that people do not understand those moves, initial moves, and sometimes those moves only make sense way later in the game. And the difference is between those two systems, why I mentioned them, that Deep Blue was a supercomputer, basically a brute force which of trying to win the game with a human. Basically had a library of many games, and was trying to utilize the library as a decision-making system, versus AlphaZero basically got rules access to the rules, chess rules. Apparently, it needs to know how to play the game, and then in the way of training it, it play with itself for like 6 hours or something like that, and then it plays with Stockfish, and won like 30 games out of 100, I think, and then didn't lose any of them. So it tied the rest of them, I guess. But that gives you the idea of this is not a brute force anymore. This is something which is happening in that cognitive side. I'm not saying conscious side, cognitive side. That those machines are actually learning something which maybe not the same as we do, but there's a huge potential in that. That's why I'm saying that upper part of the pyramid, it's very, very intriguing, especially in the data space. So I don't know if you have any questions. You probably know that you can ask some questions, right? Let me see. I don't see any, Rakesh.
I don't see any question either. So if anyone has a question, please type it in the question box.
So I'll continue. I'll try to stop from time to time.
Okay.
So let me continue then. So now we're moving to the data architecture. So when you look at the enterprise architecture, there are 4 domains, and data architecture is one of them. So what is it then? Well, I took this definition from Wikipedia, except the tiny diagram, I put it myself, so I'll explain that. But the definition is coming from Wikipedia, and it's basically a very simple definition. That's why I like it, because it says in information technology, data architecture is composed of models, policies, rules, or standards that govern which data is collected and how it is stored, arranged, integrated, and put to use in data systems and in organizations. And I thought, well, what could represent that, and especially give you some kind of idea what you need to do in this space in your project? And I thought, well, this is probably the best way to give you some kind of a highest level of understanding what you need to do in the information space. So think about it this way. The data collection is one of the aspects which you have to deal with. You already know that the data is going to be collected through your application. Your application is going to have some kind of interfaces. Those interfaces will be used by smartphones, tablets, laptops. So you'll be able to collect this type of data through your application, and whatever you collect through your application, more or less, it's known what you're looking for, because your application is going to tell these people what type of information and how they're supposed to put it, and where, and what other information they need to attach to it. But there's another part of the data collection, which is the sentiments coming from something like Facebook, maybe from some kind of other social media. And you have to figure out how this data collection is going to work, not only through your application, which you have a full control over, but also from the sources, which are completely different. And the data may be actually presented to you in different format. Maybe it will be presented as an upload, depending on the license model you can actually get, maybe with Facebook. Maybe as a streaming. If it's a streaming, how should you look at it? Should you look at it in real time? If you start looking at it real time, what does it mean to your architecture? So all these data collection points are going to basically dictate how your architecture is going to start shaping. Now, as soon as you start enable the data collection, you have to decide what you're going to do with this. Are you going to keep it? Are you going to just look at it, and if there's nothing interesting, you're going to just drop it. Are you going to store it just for maybe auditing? What are you going to do with all this data? And if you recall in your BRD, you had a data section in there, which was classification of the data. That classification of the data is supposed to help you in that decided which data you need to keep, and then also will help you to define or architect the proper data storage. The data storage need to be encrypted, all of it, and maybe some of it could be exposed. Do you need to hide certain information from certain people? Do you need a proper data access control, and so on? Now, since your data may come from different sources and it may come in different formats, you also have to start thinking about data integration. How are you going to stitch this data together in some kind of meaningful format? So maybe you can improve machine learning capabilities, because you're going to augment this data with maybe additional stream of data, which is two of them are going to complement each other. So data integration will need to happen as well. And the data arrangement is basically organizing this data in a way that it could be used. It could be used by various type of users. If you're a user who's going to basically record an incident, that's a different interaction with the system than maybe someone who's going to attend those cases and maybe represent them, or maybe will be managing them. So all of those four components are kind of like related to the data usage, because the data usage in general sense, which is what your application wants to do with this data, is going to tell each component how this component needs to shape. And there's in architecture, you probably know by now, there's no like a one prescribed way of doing things. There's many different ways of getting to the same end, especially now in a data space where we have so many different tools available to us. So I mentioned already John Zachman. There's many different visuals for his framework, but this is probably the simplest one. And I highlighted the part which we are going to cover today. So the data, and the data, he basically breaks this whole architecture into groups, and this vertical group, which is basically highlighted, it's called what. He has what, how, where, who, when, and why. And that what, in our case, is actually data. And it starts from the very high level, from requirements through conceptual model to the logical model, and then to the physical model, which is specific to the implementation, and then basically implementation by itself. So this is something which I think you should look at least one of those frameworks. Zachman seems to be one of the easiest to grasp the idea of what architecture framework means. Definitely it's not complete. Even Zachman, I think, tries to position it as the lacking implementation, which, for example, TOGAF, the Open Group architecture framework, is very good at. But this is a good starting point. Actually, many companies have been using the Zachman framework for many years, and you can organize you can organize enterprise architecture based on it. So implementation is it's a little bit tricky in here because it's open. It's not covered in here, but definitely from the ontology point of view, it's an excellent architecture framework. So I mentioned to you that it's a very interesting space, and the data landscape. I was just typing that last night, and I thought This is definitely not the whole list, but it's a long list, and we could spend lots of time just discussing almost every single aspect of it, from data creation, which I already mentioned a tiny bit, through data collection, data exchange. Data exchange is another aspect, like in your project, which you need to figure out how to share certain maybe statistical data with maybe some other universities, with similar systems. Data preservation I already mentioned, right? Data integration, presentation, and visualization. How are you going to expose this data in a meaningful way? Like, how are you going to show this data either as a screen, either as a report? Would you be able to create some kind of charts maybe to help whoever is going to look at this data to understand this data better? So there's multiple ways how you can help to interpret this data. There's definitely organization of the data. You're organizing data through data modeling. You start that. This is one of the first exercises in a data space when you try to organize this data. Then you create the data catalogs, which basically tell you what you have available at any point, and you can expose those catalogs to people who are looking for this data, maybe through some kind of a discovery service with self-service where they can write their own queries in case you don't have those reports available to them. I also mentioned data quality just a little bit in the example, but there's also something which allows you to check the data, how accurate is your data. So there is a bunch of tools, we call them data profiling tools, which allow you to do this. Definitely data governance it's needed to make sure that you're actually getting a good quality of data. And there's a whole big concept about data warehousing, data marts, business intelligence, which is the reporting part of the data. So remember on the pyramid, the bottom of the pyramid was data. The next one was the information. That information comes usually from business intelligence. The business intelligence basically presents this data in a way that business wants to see it, understands that, and then is able to act on it. So that's how they build the intelligence. Then there's a whole concept about metadata, which is a way of describing the data in a way that you can start looking at this data in a different way. Then we have master data, reference data, which is augmenting the data with a consistent view of the data and presenting in a consistent view across your enterprise, especially when you work for a larger company. That's what you want to do. You have a data federation and data virtualization technologies which allow you to have access to the data without copying this data. And of course, with the last probably like 10-15 years, we got big data, unstructured data, Internet of Things, where machines generate lots of data. Google bought Nest, the tiny device which you installed in your house to keep you warm in winter. They paid like $5 billion for it. And if you start thinking about it, that device, definitely that device, they're not going to make profit on that device. What they're after data which that device generates. So the data when you're at home, what are the habits, what are the patterns, all that is collected by Google. So that's Internet of Things. And there's NoSQL, which is doesn't mean NoSQL, but it's not only SQL, which is albeit on the side of unstructured data and big data. Then we also open cloud to computing, to data as a service. We still have the split of the data between on-premises data centers, which most of the companies have, and the data in the cloud. We also got, after big introduction of big data, we also got the concept of data lakes. a relatively inexpensive way of storing lots of data, regardless of the type of the data, and ability to process this data as well. We got data mining, which allows you to start looking at the data especially in the extremely large volumes of data, in a way that it starts making some sense, like a pattern recognition and all that stuff. We definitely have data science, which becoming very hot recently, especially in the space of artificial intelligence and machine learning. And we got lots of improvement in data encryption thanks to Bitcoin architecture, with the concept of a blockchain, which almost every company is working on, and distributed data concepts. And the list goes on and on. And I mentioned dark data, and you think I made it up, but you're probably aware of dark matter and dark energy, the concepts which we introduce in our physical world. I don't know if you know, but we only know about 4% of our world. The 96% it's unknown, and we just ignore it and we call it dark matter and dark energy. But we also have dark data. It's a very similar concept. There's actually more dark data than visible data. And dark data is the data which you collect but you never look at, and everyone's guilty of that. Questions so far? Let me see. Well, I don't see any questions.
Yeah.
So I'm moving forward.
Yes. If anyone has a question, just type it in the question box. Thank you.
We're like halfway through.
Okay.
I'll speed up at the end because I have like a few examples. I don't have to talk that much about that. You can probably watch it later on. We are recording, right?
Yes, we are.
Okay. So in case you missed something, you can probably replay that. But then we're moving to that initial part which I mentioned, data modeling. And I already mentioned when we were talking about this Zachman framework that we have levels of looking at data. When we're talking about data modeling, usually we have those 3 levels. We have conceptual data model, logical data model, and physical data model. And if you're approaching something as a greenfield implementation, usually you start from the top down. The reason is because you need to understand first what you're trying to do before you get physical at that bottom. So the conceptual data model, it's actually also, I think it's also used to be at least called subject area modeling, although subject areas are still part of it. I don't think that, maybe you actually can hear that too from someone, but conceptual data modeling, it's a very high level of understanding of what you're trying to do, how that something, how something works, and think about it from the key business concepts and rules. So the idea is that you're going to look at this from the like a high level where you don't see the detail level yet. So you see the entities, think about tables kind of approach, but you don't see any attributes associated with those tables. So you only see like a customer, you only see order, but you don't see what that customer is made of, what kind of fields you actually tracking, what kind of information you're tracking about that customer or that order. But you will see the relationship between them. So the relationship you want to define in conceptual data model the best you can, and you build that those entities and relationship based on the what you're trying to accomplish as far as the business concept goes, and you try to bake those rules into the conceptual data model. So the conceptual model is a pretty picture which describes the business from the data perspective. Now, logical data model, it's a detailed business solution. And the business solution means that it's looking at the data model purely from the business, not from implementation, not from technology. It's basically representing business as close as possible with all the attributes which business wants to track and needs to track, with all the information which you're going to later use to build a physical data model. And physical data model, it's basically implementation of the logical model based on some kind of technology. So if you decide on a database management system, that DBMS, you will most likely take a logical data model and convert that to the draft version of physical data model. And then you start optimizing the physical data model for performance. And that would be specific to your database management system. Each database management system has a slightly different ways of optimizing their systems. Let me think. No. Let's move forward. I'll come back to that then. I had some thoughts about the tools, but in general sense, the detail level, it's slightly tricky. In your sample, which was sent to you for the next deliverable, I stole one of those diagrams, which is this one. Think about it this way. If you look at the left-hand side, I have LDM and PDM, logical data model and physical data model. And when you look at the elements, what they're comprised of, you'll see the entity attribute, which are specific to LDM and conceptual model. But then when you move to PDM, we call them table and columns. So it's just a fancy name of when you're talking about entities and attributes, everyone knows that you're talking business language, versus when you talk about table and columns, we're talking about specific implementation in the on the physical database management system. And the same with domain and data types. Domain is a little bit more like a generic data type. You can say like a string versus varchar 27, right? Number versus integer, something like that. So there will be different ways of basically generalizing. So LDM is generalizing the data types, unless it knows specifically that it needs that. But usually it still has data types, and it depends on implementation. Again, in some places you will see that LDM will have exact the same data types as the PDM, if the modeling tool permits. But in some cases, they will be actually crafted in a very interesting way. Why? Because if you think about that you want to have some kind of consistency across your models, you will create certain, let me call them data types in logical data model, which is going to be consistent for the company. So if you're going to say that employee number, it's a 7 character long alphanumeric field, then and it has a certain pattern, like a zip code, right? Then you're going to enforce that through your system. And then anything which uses that employee number, it's going to basically refer to the same structure of the numbers. So even if you have to reconcile, if you have to integrate, it's way easier. And then when you translate to the data type may be depends on the definition of that field, on that attribute in the logical model. It's going to be maybe character based, maybe depending on the type you're going to create. So this is just showing you what are the specific ones. There's lots of overlap, like relationships, cardinality, primary keys, foreign keys are basically the same concept. And then in the physical implementation, since we're looking at the performance, we're usually looking at indexing, partitioning, distribution of the data, and so on. Now, on the picture which I took from your deliverable, that basically shows you the level, what you need to do. Let me see what's missing in here, because I thought there was something missing. Conceptual, I think it's actually spot on. Usually you don't go beyond entities and entity relationships, so entities and relationships. Sometimes depending on the place, you may actually have in conceptual, you may have main attributes, which allow you to create like a kind of primary foreign key constraints, but usually you don't have it. Sometimes you do, sometimes you don't have it. So this is more or less what you're looking for. The logical, entity names, relationships, attributes, primary keys, foreign keys, definitely there. I think what's missing maybe, you have column data types, but you don't have domains. Basically, you don't have the logical data types in here. And you need to specify that, because that's related to the business rules, how business wants to see certain type of data. So I think that's missing in here. That should be probably added. And on physical, I think that's good enough. And then you'll have more stuff like index partitioning, schemes, and so on. I see some questions. Let me see quickly. I have a tiny window, so let me see if I can resize that. So the question is if LDM is just generalized version of PDM. Otherwise, the structure relationship model will be the same. It depends. So yes, it is generalized, but think about it slightly different. There's a concept of generalizing certain aspects of logical data model, but it's more important to represent business very well. So sometimes business, so logical data model will represent basically what business, how business perceives data. Now, in physical model, some of those generalized concepts may not be feasible based on the database management system of your choice. But usually what happens if you're using data modeling tools, I mean like professional modeling tools, not like a, flowchart, then when you create a logical model, you go through the review process. So you review this with business, you walk business through this model. Business says, yes, that's how we perceive business, or no, this relationship doesn't exist, or no, it's reversed. We have this relationship does not exist in here. It's actually we're connecting to this through some other means and so on. So when you review this logical model and it's approved and it's truly showing the data model which reflects the business, then what you do in the data modeling, professional data modeling tool, you use that as the base and you link a logical model to a physical model. Basically, you generate physical model, and that's your first draft of your physical model. And then you start basically removing anything which is too generic or maybe even too normalized. And then we have a concept of denormalizing data, creating different data structures in physical model to optimize the usage of data. And the driving thing for the physical data model, it's when you know how data is going to be used, you're trying to optimize this data structure for the usage. So you're trying to create something which is going to have that response time which maybe business is expecting to have. if you click on a field which is pull down field and nothing happens for another 5 seconds, most likely you're going to think that the system is broken. But if that pull down field pulls like maybe 500,000 records, nobody's going to look for it and scroll through it, right? So that's kind of the ideas behind it, that you need to optimize your system for it. And there's a different optimization for the system which deals with one record at a time versus reporting system like BI, business intelligence, or advanced analytics, which deals with like millions of records at a time. So now the other question is, which one is the ERD diagram, entity relationship diagram? All of them are actually entity relationship diagram because all of them have entities and they have relationships. So it's basically all of them. So pose the questions. I'll stop after a couple of slides or so. So I borrowed this picture from that sample which you got, and this is the sample for conceptual data model, and I think it's a decent example. So there's multiple ways of looking at this. Usually what we do in conceptual data model, depending on the size, of course, everything depends on the size, but if you're doing the conceptual model, usually you're trying to carve out a piece of real estate and target that. So what you're doing, you basically, let's say you're interested in human resources. So you do that conceptual data model for human resources, and then you do the finance, and then you do supply chain management, and so on and so on. Eventually, you're going to have those subject areas, and then you will see the relationship between them. So your model is going to grow, but usually you will become, assuming you're professional, you become like, you know, after dealing with business for many months or many years, you'll become like a very well trained how to present this model to business and how to validate that. So definitely you're looking at few things out of this conceptual data model. You want to capture some kind of requirements on a very high level. So in this case, you will see that the level is the entity level. There's no attributes associated with any of those entities. Each of those boxes is basically entity, and then all those lines which are pointing to some of them or connecting some of those boxes, which we call entities. Those relationships are defined by business concepts. So we know that an order has an invoice, and the order could be delivered by shipment, and the shipment can be tracked by tracking system. So those verbs which are here on that associated with the relationship basically define this type of this relationship. So those verbs are very important and in conceptual data model. And usually you think that something like that has a little bit of meaning. Just don't put like has everywhere, right, or is, because sometimes that makes sense. Like in this case, it actually makes decent sense, but usually don't put the whole sentence, but usually make it meaningful. So you're learning something through this relationship, through this verb, not only through a relationship between two entities, but also the verb which describes the type of that relationship. And definitely defines the scope and direction. So if you're building some new business functionality, like in your case, you're building a new system, then this model tells you what else you need to cover. Or maybe you forgot to take care about the tracking system, but you have it in here on this conceptual model. So you know, okay, I tackle customer and order and shipment. Oh, I forgot about this module. So then you'll figure out how this tracking is supposed to look like. So this is the idea of also, it gives you some kind of idea of the scope which you need to cover. The other thing is, as I mentioned before, that you can do you take this model and you present this model to business. You don't present it as a picture. You actually walk business through this model, and then business validates that. So what you get this proactive analysis, which could be done on this model. Although this model doesn't look like much, but a business can tell you that, you know, that tracking system is actually not done in here. We ship through UPS and we never actually have the tracking or ability to actually even track it. So that's wishful thinking, but we don't have it. So at least you know that that's not in our system, or maybe that will be in some kind of other system where we need to bring this data in, and there's some kind of service we need to sign in for. And definitely, you're building a rapport with your business, because every time you go to business, they validate that, you talk, you walk them through, and they become better in interpreting this model, and then you become better in understanding the business. The conceptual model for multiple reasons, you have to be very specific in here. Those relationships are very important. So you probably can't read this, but this is this notation in here. It's a specific notation. We call it crow feet. This weird sign in here, but you interpret it in a very specific way. So this tiny bar in here means one, and this crow feet, which is in here, means many. So the idea is that this is one to many instances of the shipment part of the order, and vice versa. So we call it many-to-many relationship. And this one, it's one to many relationship. The same about this one, and this is many-to-many. So that relationship is important. So keep track of it. Now you see that there's no verbs in here on those relationships. If you had the modeling tool, those relationships will be well defined, and they will have the definition of what that relationship looks like and what it means. Each of those entities should have definition. So it should have the dictionary, which basically defines every single entity, what business means by customer entity, what customer means from business perspective, what order means from business perspective. If you had sale, how do you recognize that the sale is a sale, right? And there's certain business rules in some cases which actually dictate which transaction is considered as a sale versus just an order. So there's a number of things which you will have to model, and those relationships basically play a crucial role. And usually you spend lots of time with business validating those relationships. It's easier to validate what is the content of the entity, what are the attributes in here, but the relationships play a very important role. So definitely you want to depict business roles, and this is important as well. This model is independent of technology. You're not thinking where this model is going to be deployed. Is it going to be deployed on SQL Server, Oracle, Hadoop? You don't care. This is the logical representation of the business. business rules and business processes from the data perspective. So now, this is the interesting task. In order to get some kind of efficiency in this model, we go through the process which is called normalization. And normalization basically takes the starting point, which is defining some of the entities, and then as many attributes as you can think your application will need, and then we'll try to figure out if that entity should have all those attributes, or we should split it maybe to two different entities, and what would be the relationship in that case, right? And we go through this process, which is usually we try to get at least to the third normal form. 3NF means normal form. And this is the process of normalization. And basically what it is, it ensures that every data element is fact about the key. So that's how you achieve the first normal form. The whole key, second normal form, and nothing but the key, third normal form. And I minimize the effort of normalization. Usually you spend like a day at least learning what normalization means and how do you actually do it. So you have to work with your mentor on that. Maybe we'll find you some kind of good online training or some kind of reading material. Because that's a large topic, and some people get it immediately, some people struggle with it. So don't be discouraged if you struggle with it to begin with. It becomes almost a second nature after you've done like, let's say, few of them or a few hundred. So what I did in here, I gave you some kind of reference points, kind of like a basic scorecard, and to validate if this model is good, it meets the passing bar or not. Definitely what you want to go after is capture the requirements, business requirements in this model. So in your case, your system requirements coming from business, from BRD document. Definitely you need to represent the business. This is not for the sake of having a nice picture. Naming standards. So I can point you to some kind of violations in the logical model. You do not use any abbreviations. You don't use anything like F_name. You use full names, no, with spaces, no underscores. This is not implementation. So you do not use anything like this. So you will most likely you will spell customer identifier or customer number. You wouldn't put like ID in there. So now, since it's a primary key and there's a concept of a surrogate key, sometimes those surrogate keys are introduced in the logical model. And again, this will differ per organization. If you have like a large organization where logical models are done way ahead of physical models, because those architects or data models trying to line up the business with the logical models or logical models with the business, then this may be done ahead, and they may not even have those customer IDs unless business perceives customer with a customer number or customer ID. Then, like, social security number, it's a known number which is used for multiple reasons, right? To track unique individuals. But in general sense, you will spell these attributes with the full business name of these attributes, like how business calls it, not how it's going to be implemented in a table. If you're familiar with SAP, German company which is famous for process integration, they have those cryptic names, and I think the longest name it's like 8 character long or something like that, and that gives you the idea that nobody can actually reading from the direct names, it's meaningless, because that's the implementation layer. So you, in this model, you do not use any abbreviations, you don't use any shortcuts, you use the business names for attributes. So definitely follow naming standards. Good definition. So each of these entities, so big boxes, they need definition, and that definition would be stored with the business, with the logical model. If you have the data modeling tool, that will be stored as metadata. So there will be additional, like, if you open properties of this customer in the data modeling tool, professional data modeling tool, you will see that there's lots of information which could be captured about this. And one of them, which is the most important from the business perspective, is the definition of that entity. Definitely you want to arrange it for readability. And there's again, if you don't have the professional data modeling software, you do this by hand. You just arrange it the way that you can actually see them and you perceive the relationships. We have just 5 entities in here. When you have 500 of them, sometimes it's extremely difficult to organize them in a way that they're actually in a readable format. So definitely you need to arrange them for readability. And then you try to make sure that you're not breaking any rules, especially with the normalization and the relationships and so on. Now, again, if you have professional software, it helps you. It has a validation. You can plug your own rules to validate certain aspects. You can plug your naming standards in there, which is going to basically find all those anomalies and sometimes even correct for you if you want to. So you run basically validator. Validator tells you that there is a number of naming standard validations. And then violations, and then you basically say, okay, fix them, and it knows how to fix them, and it will put spaces, put the full names, and so on, so on. So there's multiple aspects of the professional data modeling tools which will not be covered just in here. So I think in your deliverable, you basically have to build this model, and you can build this model anywhere. It doesn't matter what tool you use. But then you have to create a data dictionary for each of those entities. You need to create a definition, a business definition, and for each attribute you need to have a definition as well. We also have the concept of the data types, which I mentioned before. This varies per company. Sometimes those data types will be borrowed from physical data models. Sometimes they will be specific to logical. Bigger the company, more organized that thing is, and most likely it won't be varchar 100. It will be most likely string, or even it will be probably not even that. It will be like a part of the domain name, which is like a first name, and then it will resolve to the proper data type. So what you do next, you take this model, which you already developed in your data modeling tool, and you generate the physical data model. And then after you generate the physical data model, which is specific to your database management system, let's say Oracle, it will translate all those data types to their proper data types. You validate that, you run some validation tools on the top of it, and then you have ability to do something which we called forward engineering. You are able to generate the DDL script, data definition language, which is basically a script to create all those objects in that database. In our case, like Oracle, let's say, right? So that's the power of the data model. That the data model starts from the top, tries to organize this business solution from the data perspective, and then goes to the logical data model, which is fully attributed data model, with all the relationships, data types, all that stuff, definitions, and then you get the first draft of physical data model out of the box without any cost, and then you massage it for performance, and then you forward engineer the script, so you do not write the script. So just imagine you have 500 entities in your model, and you have to write the script to create each object and each relationship and each primary key, each foreign key, each constraint, and so on. That would take you a while. So this tool helps you. And in most cases, you have the versioning inside that software with a repository which is sitting on some kind of database, which has backups and so on and so on. There's lots of benefits of having a true modeling tools like professional modeling tools. So I don't know, at least I haven't worked for any organization which wouldn't have a professional data tool. Erwin is probably the most known, longest probably on the market. There's Embarcadero, Data Architect, or something like that. And there is a Power Designer from SAP. Those three, I work with all of them. All of them have that kind of capability and way beyond that as well. So before I jump to the next one, I see some questions. Let me see. So the question is, in logical data model, we go to first normal form. Yes, we do. That's our goal. We try to go to the third and F normal form, because that gives us the, without spending time on normalizing, that gives us the ability to make sure that that our data model is very consistent. It holds the water. It doesn't have any unnecessary redundancy. It doesn't have something which is going to create some kind of anomalies in our data when we forward engineer that using a physical data model. Plus, this is the only exercise which you truly go through with business, because the next one on this level, on this detail level, because the next one will be physical data model, and you never review that model with business. So you never actually do that with business. So physical data model, usually you talk to your DBAs, database administrators, to help you out to basically create those additional things like partitioning, indexes, and so on. So there's another question. In case of NoSQL solution, if there are no third normal form kind of normalization, then would the LDM look like? So don't get confused by NoSQL, schema on read, approaches, because that's a physical implementation of your data. Before you get to the physical data model, you still have to create this, because you do not create this to instantiate that in Hadoop. You create this model to validate that the business is well represented from the data perspective. So you still go through logical data model. Your physical data model may be completely different, but there will be mapping between this logical model and physical implementation. Even if it's key value pair, you can still map entities and attributes in here to the proper structure in Hadoop. So that NoSQL solution does not change this. You still normalize this model. There won't be any relationship between big fat tables. The relationship will be there, but you do not store that in the database itself in the way you store this as an object. So in the relational database management systems, those relationships, those lines, will be actually represented as a database object, and they will be created as a relationship between those two entities in the physical model between those two tables. Now, when you put this data in let's say key value pair, you're still going to mark this data with metadata. You're still going to stamp this data, even if it doesn't have to be key value. It could be XML format, it could be document format, it could be JSON type. Doesn't matter what type you're actually going to get. When you ingest this data and you know about this, because this is representing your solution. Your application is going to basically utilize this model. So you know exactly what your application is going to capture. So in order for you to stitch this data into a consistent record, you will still need to stamp this data with additional metadata keys. Either some kind of GUID, maybe saying that it's a part of the same table, is the part of the same record. Maybe you actually say that it's a part of when you do the data integration, that when you're building canonical data models, you're going to say that the customer information, which is related to his first name and last name, and the phone number actually comes from one system, and then it's augmented by some kind of other system which gives us a proper address and zip code or something like that. So you will still stamp it with metadata. Good questions, though. Thank you. So now, I'm going to give you a few patterns. I'm not going to spend much time on them, but it's good for you to understand them, because unless you understand them, most likely you will be trying to, how should I say it? If you understand them, even if you build something which looks weird, like a Frankenstein of approach, at least you're doing it consciously, so you know why. And since we have so many different data technologies available to us now, there's a lots of possibilities how your physical implementation is going to look like. So I'm going to introduce you to a few data patterns. I'll start with the traditional relational database management system workflow. Think about this. OLTP stands for online transaction processing, and I borrowed this from Microsoft, so it has a SQL in here, but it doesn't have to be SQL Server. It could be Oracle, it could be DB2, it could be anything. The idea is that online transaction processing usually has a slightly different expectation from the data store. Either it collects data and stores this data in a database, or it could be flat file, doesn't matter, but some kind of a data management system. In traditional, usually it's a relational database, but it doesn't have to be. But it also, when you point your application to it, usually it deals with one record at a time. So usually what it expects that you're going to, you may have billions of rows in here even in a single table. So when you're trying to find something in there, the expectation is you say, okay, give me a sales record for John Smith on January 15th, 2018, and then you expect that record is going to come to you immediately. You don't expect that you're going to process this data in Hadoop or something like that, which may take like a few minutes before you actually see the record back. Because the guy is trying to return some items in your store. He's not going to wait another 10 minutes before your system is going to tell you that yes, he bought this item at your store. You'll be losing business very quickly. So the idea is that the online transaction processing system usually collects lots of data, like you go to the store, you collect lots of sales data, you go through cash registry. Each cash registry is going to basically record every single transaction and the details about transaction, what you bought it for, what price, what was the discount coupon, and all that stuff. But also when you try to return this item, you have to be able to query the system very quickly. Usually what happens after and you could have multiple systems, multiple databases as part of your OLTP solution. This diagram shows one, but doesn't mean it has to be one only, right? And then what you do, there's a concept of data warehouse where you basically take all those data sources and pump this data to your like some kind of logical representation of your data. Usually it's a physical store, and right now with the options of storing large volumes of data in data lake, for example, you have abilities to do this relatively easy. What you're trying to do in here, you're acquiring the data, but you're also trying to integrate this data. So if the data comes from different sources, you try to present this data as a one consistent system. Then you present this data to a business intelligence and analysis. So you present this data in a way, usually you build some kind of performance optimized models. In the traditional way, it would be the dimensional model, and there's a couple of them in there, or you can start using a dimensional model and then build some kind of aggregation of this data. The idea is that let's say you have like 10 million transactions every day coming from 1,000 stores around the world, and they're pumping data to your OLTP systems. The data is actually either copied or replicated or sent over to your data warehouse. Data warehouse does the data integration, tries to put this data together in some kind of consistent storage, and then what you do, you build your model, analytical model, which is a dimensional model, which allows you to query this data for volume. And the volume means if you had 10 million transactions and each of the customers bought, I don't know, 10 to 20 products, you have easily 100 or 200 million rows every single day pumping into your system. You are not going to show your business 200 million rows every single day and ask them to make decisions for the next day. Should they drop their product? Should they keep the product? Should they buy more? Or should they distribute more? What you're going to do, you're going to organize this data, that this data is available to them in the way that they can actually make decisions on it. So you aggregate this data, you organize this data maybe by location, maybe by region, maybe by store, by date, by product. Maybe your finance wants to see if you're making or losing money on the product. Therefore, what you're doing, you want to create a model which will allow them to look at any product across time, season, store, region, whatever they may be thinking about looking at this data and making sense of this. And they can easily see if they're losing money, they're making money, if they should drop this product or they should continue that relationship with the vendor and that product. And then comes the reporting part. And the reporting part is something which basically you expose to your users. So you're trying to create some kind of meaningful report, some kind of meaningful interfaces where they will be able to start looking at this data, and also not static. Usually you create some kind of dynamic ways of organizing this data. They should be able to at least filter. They should be able to slice and dice, we call it, data, meaning that they will be able to run it through certain hierarchies which are specific to the business. And then at the bottom, we have ETL, which stands for extraction, transformation, and load, which is basically a traditional way of getting data from operational system to the data warehouse and then exposing it through dimensional modeling to the business. Whew, long story. Since I mentioned ETL, there's also ELT, which is ETL, extract, transform, load, extract, load, transform. I just put this because I ran across the pictures and I'm thinking, oh, that would give you some idea what I was talking about. It's just, this is the traditional one, which was on the previous slide. Now, since we try to bring the data processing to the data itself, to the database, closer to data. And if you look at the big data is doing exactly that. They're bringing the code to data, not the data to the code. So you're not pulling the data from the system, you're bringing code and you're running that code on every single node where the data resides. Just a different approach. Since there was a question about big data workflow, it's slightly different for few reasons. If you look at the top one is it's reading from the message queue. This is the icon from message queue, but it doesn't matter. You can use whatever you want. But this is the data queue, basically message queue. And that's probably good advice regardless of what kind of system you're using, traditional or big data or anything, data streaming, that you use some kind of way of separating the components. You do not try to link them directly. So one system should have some kind of buffer And the message queue is one of the good examples of that buffer, because what you can have in here, you can have lots of data pumped into this message queue, and then assuming that whoever consumed this data cannot process this data in that speed, they can basically, the message queue is going to accumulate this data, and then it's not going to break the system. Even if the system is down for, like, let's say an hour or so, this data will be not lost. So ingestion of the data will still happen in that message queue. And of course, you have to size this message queue properly. But usually what you do, you build it as a scalable system. So now, when you get this, what you do in here, since this is message queue, this is event-based, you read that, and then you use maybe something like data streaming, like Kafka, and then you look at the data stream, basically one message at a time, and you can make decisions on the fly. Basically, if your system is lined up properly, sized properly, as the message comes in, it gets in here, and it's already going through the process. So it's almost like at the split of the second, you go through the whole thing, and then you decide what you want to do. Do you want to store it in a storage, or you want to drop it, or you want to store it and then reprocess it, or do something more interesting with it? In this case, it's actually storing this all that information in the data lake. And then what you see at the bottom, you see slightly different pattern, because what you have in here, you have Internet of Things, basically generating lots of readings from thermostats, some kind of, I don't know, traffic lights, whatever it is, Tesla cars. And then what you do, you drop it in the key value per system, like Hadoop in here. Basically, you process it, and then you store it in here, and then you process it in the as a MapReduce concept, which Hadoop introduced. This is actually Cosmos, so it's slightly different. This is Microsoft again, by the way. So now what you have this storage. Basically, you have all this data stored in your storage, and now what you do, you hook up your machine learning to it. Let me see something. Okay, and machine learning. I'll touch on it later on, but that's the idea behind it. So now you have lots of data sitting in here, lots of data, which is gathered by your smart devices, smart meters, message queues, whatever you're subscribing to, and you putting in the storage, and you're trying to organize it in a way that machine learning can start learning from it. And in most cases, more data you have, better your algorithm adoption to your patterns is going to be. And then definitely you try to present this findings to the business through some kind of reporting ability. I'm going to mention this because this is worth knowing. I don't think that you have to be an expert or anything like that, but it's good to know that there is this hot path, which was basically streaming the data through and stuff like that, and the batch layer, which was more like a traditional data warehouse approach, right? And we call it Lambda architecture because we're splitting the data into two systems. One could be like a batch process, end of day load, and the other one will be in the real time. And then eventually you reconcile them if you have to, for some reasons, or maybe you drop it. You just do the analysis in the speed layer on the top layer. Very quickly, you look for the fraud detection, something which matters as far as the split of the second or close to real time analysis. But then you could still do the larger volume of the data crunching through that lower level, which is a cold path, which is basically persisting this data for a longer time. And the Lambda name came from the Greek letter lambda, which looks like a split, almost like this on the side. This is one of the examples, again, from Microsoft Azure. And this is more or less what was shown in here. The speed layer and the batch layer. It just has a little bit more detail. It has the application pool, elastic pool, which is basically that elastic database system. and actually it says the event hub, so at least they actually have names in here. But the idea is more or less the same. It's just a little bit more more icons on the picture, right? But same pattern. And of course, Excel spreadsheet and Power BI. That's what Microsoft wants you to use. By the way, there's nothing wrong with it, and you'd be surprised how many businesses run on Excel. Powerful businesses, by the way. I mentioned to you that there's a machine learning, and again, this is from Microsoft Azure. Don't be stuck on the names, Azure, and all that stuff. The approach is very similar. The idea is you start small. You basically have some kind of local training. So you have your local workbench, you install it somewhere, you get the sample of data, you just train your staff and all that stuff. So you could do this. They broke it down into two layers. So they broke it down into the upper part, which is the training layer, and then the lower part, which is something which you basically instantiate in production. So you train your machine learning algorithm, and then when you satisfy with them, you push them to production. But the idea is you can start small. You can start on a very small scale, or you can start a little bit larger. You can have a true development management environment. If you don't know anything about Docker, it's probably time for you to read a little bit about that. It's very interesting technology of deployment. It gives you the something which cloud is basically very famous for, and everyone has ability to utilize for Docker. Microsoft has Kubernetes, which is the additional layer on the top management layer of it. But in general sense, what you do, you try to get as much as data as possible from various systems. Like we gather some data in Hadoop, let's say, and then you run when you develop your algorithms, you test them. You test them against test data, and then when they look promising, you push them to production. What you have in production, though, you have to most of the algorithms need tweaking on as often as possible. So what you usually do, you provide them with the fresh data, and more frequent data you can give those algorithms, they can adjust for the day, if you care about that. If you don't care about adjusting through like every single, I don't know, minute or 5 minutes, then maybe once a day upload, it's fine. Or maybe you're actually good for a month or so before the pattern changes. But what you're going to do, and by the way, all those services which are mentioned in here, you can actually use in your application. Let me see. Yeah. But since you're going to work with social networks, sentiments, and basically processing comments made by people, this is what you should probably start looking at: natural language processing. There's algorithms which are optimized just for that reason, dealing with the something which is unstructured text and organizing it in a way that you can start using it for some kind of prediction analysis. And I'm not going to go through this. You see similar approach, real time versus batch. But the idea is to start thinking that there's lots of machine learning going on in there. But this will be natural language processing, which you probably focus on, at least for your project. I'm not saying you have to, but would be probably a good idea. A good idea to do it. And before I jump to the questions, I just wanted to touch on this slide. So what I showed you so far was mostly from Microsoft Azure Cloud, but you can see that almost any cloud provider has its tools. And I just put this slide in there because it will give you the idea what Amazon has to offer, and it's lots of tools, and it's your choice. Basically, what's more important from your perspective is it's recognize the pattern which you need to implement, and then tools you're going to find specific tools during the implementation phase where you have to recommend them. But for now, it's more important that you recognize what patterns you need to use, and then you'll find the solutions for it. Let me look at some questions. So maybe what I'll do, I'll try to find, so Microsoft has actually lots of information about that, the slides which I showed you before. Oh, the question is, where should you start looking at if you want to learn a little bit more about machine learning and artificial intelligence? Definitely start with this natural language processing. Think about, look at Facebook. Facebook has the APIs, which they actually open up to public, and what kind of information you can get out of those APIs, and then align your natural language processing with the data which is going to come in. Then the good idea would be to start looking at one of the cloud provider. It doesn't matter which one, it's your choice. It could be Amazon, it could be Microsoft. Just look at one of the big ones. Why? Because the patterns which they have will be more or less similar. They will be just plugging the tools behind those patterns, whatever they actually make money on, right? So Microsoft will give you HD Insight, Amazon will give you Amazon something, right? So when you start thinking about that, pattern is more important, and if you go to Amazon, I'm pretty sure if you actually put a question in there saying that machine learning or natural language processing, you're going to find lots of information. The same about Microsoft. Microsoft has tons of docs which are open to public, completely open, white papers, very deep analysis of those algorithms. You don't have to go that deep, but start with the patterns. Start to figure out what you need, and then see if any of those patterns actually matches your thinking, how your solution is going to look like, and then look for something more specific, and then look at the generic pattern, how this pattern actually looks like from the top. And whatever you do, if you search Google, you're going to find lots of information. Start with Wikipedia, some give you some context, some kind of idea where to start, and then go deeper and deeper. Maybe I'll see if there's anything good, and I'll share it with Rakesh so he can post it. And the same probably goes for the normalization, because I'm pretty sure that that's going to give you some trouble unless you've done it a few times. It's going to give you some trouble. So I hope that's a little bit helpful. I probably have like a couple of slides to go, so let me finish it. So I'll give you this. This is NoSQL, and I anticipated someone will ask about that. But when you look at this, there's different type of NoSQL database. And NoSQL doesn't mean NoSQL. It means not only SQL. By the way, this was a hashtag which got adopted for the whole thing, but never intended to. But nevertheless, I'm giving you like some kind of ideas what type of non-relational databases you can run into a columnar, key value, graph, document, and what there would be the use scenario, and then vendors, so you can map it to the specific product, and maybe you'll read a little bit more about that. And definitely, when you think about your application, cloud development, there's lots of challenges. I put a link in here. It would be you can actually look at this link, because this link have the architecture patterns which I mentioned before from Microsoft, and that's pretty you can get lots of information. There's lots of reading about that. So if you follow this link, and I'll give it to Rakesh to send it to you. But that could be a starting point if you want to give it a try. And they also have patterns for machine learning and big data. And that's it. 8:30, an hour and a half. Well, thank you very much. You were very patient.
So anyone, if you have any question, this is the opportunity to ask a question to him again. Pause for a few more seconds. It seems like you explained it pretty well, Lucas.
Or said too much.
No, it was not too much. So actually, thank you for walking us through the history and explaining data pyramid very elegantly, and going through the data definition, data classification, and walking us through the conceptual, logical, and physical model, which is extremely important. And then different types of data patterns. It was I myself, I learned a lot, and I hope our students learn a lot too. Thank you so much.
Well, thank you for sticking so late. If you have any questions, I think if they send it to SITAC, you're going to get those questions, right?
Yeah, I'll get
Yeah.
those questions, and then I'll forward those questions to you.
Yeah. So if there's anything specific you still missed, maybe you replay it or look at it back, and you still have questions, ask Rakesh, and I'll help out if I can.
Absolutely. And I'll share the recordings in our YouTube channel, and also the PowerPoint slides that Lucas presented. So thank you all.
Thank you. Good night.
Good night, everyone.